Welcome to the CHEM 2125 lab. Today we are going to be working specifically with the benzoyl condensation. So in the synthetic route, we are actually in chapter 48 of your book. So you can go there to check, for the for all the detailed information and mechanism regarding up to this step. This is the reaction scheme for the benzoyl condensation. As you can notice, we are going to start from a one benzene skeleton. It means our molecule has only one benzene in the structure, and we are going to form a two benzene skeleton molecule. As you may know, this is very important for when you do your calculations and you put the stoichiometry or when using the stoichiometry of the reaction. And so make sure you understand and you take into account this key aspect of the reaction. So in the benzoyl condensation, traditional approach involved cyanide ions as the catalyst, but the cyanide mechanism is highly toxic. The cyanide is highly toxic and is not used in our organic chemistry teaching lab. Despite that, this cyanide mechanism is outlined in detail in your book, so you may go there and study that mechanism, since can be useful or can be asked to you in the final exam or in any kind of exam that we do have. We will have it. In this case, we will be using thiamine, which is vitamin 1, as an alternative catalyst, which is more natural and less toxic, so it's more safe for us. This is the reaction mechanism. So thiamine exists as a salt, thiamine hydrochloride, and the anion can vary for some reagents. In this case, we are gonna be using the chlorine as the contra anion for this molecule. So in the first step, we are gonna have a basic hydrochloride that is going to remove one of the protons from the thiamine hydrochloride to further form this sweet ion species that is shown here in the right. So we are going to simplify the complexity or the structural complexity when writing of the molecule by putting as an R1 the blue part of the molecule and R2 the green part of the molecule. Since we are mostly interested in this hetero ring that is shown here, right? In order to simplify the structure. That's the only reason. We're going to have two charges, as we mentioned before, the negative charge on the carbon and the positive charge on the nitrogen. The negative charge is going to attack the carbonyl of benzaldehyde, and it's going to incorporate the benzaldehyde molecule into the skeleton of the molecule. That way we are going to be forming this species over here that still has the positive charge on the amine, and the negative charge is going to be transferred into the oxygen. The oxygen is going to be then protonated by the effect of water, and as consequence we are going to get the corresponding alcohol and still the positive charge is going to be over the nitrogen atom. Then another hydroxyl is going to remove another proton from this skeleton, and we are going to generate again another sweet area molecule, in this case with the negative charge in this carbon over here, and still the positive charge is going to be on the nitrogen. So here in the bottom we're showing the resonance structure of the molecule that we're going to be using and the most stable resonance contribution of the molecule, right? So the double bond is actually going to migrate into the benzoyl junction with the catalyst, and that way there is a more stable resonance contribution. Yet in this interchange there is going to appear another benzoic molecule, and this skeleton is going to attack another carboxylic group of a benzoic molecule, benzaldehyde molecule, and similarly is going to transfer the negative charge to the oxygen of that benzaldehyde. Then again, the benzaldehyde molecule is going to be incorporated into the whole skeleton of the structure. So we will have three skeleton species. So we have the two benzoyls and the catalyst in this species. So here it shows how the negative charge is going to be transferred to the oxygen of the other benzoin by removing the proton from this alcohol and generating a new alcohol group and forming a ketone. And by effect of that, the catalyst is going to be expelled and is going to be regenerated. Catalyst means that this molecule is ready for another attack and for another mechanism similar to this one, right? So this molecule is consumed using the mechanism and is regenerated by each of the products. So this molecule is able to be reused for each of the benzoin products. It means that we can use less equivalents of the catalyst to make much more reactions, right? Since just a small amount can be reused for a lot of reactions, right? For the experimental procedure, we are gonna do the following. First, we need triamine hydrochloride, 1.04 grams. Second, we need to add 3 milliliters of water, and then we should be able to dissolve all the salt, the triamine hydrochloride into that amount of water. Then we need to add 8 milliliters of ethanol, 95% minimal. Add 3 milliliters of aqueous 10% sodium hydroxide solution. Then we need to add 3 milliliters of benzaldehyde. And in futures and in upcoming slide, we are gonna see how we can purify it if needed. The benzaldehyde. Mix thoroughly after each addition and keep up to room temperature for overnight, and Of course, you will need to complete the synthesis of benzoin at your next class meeting. By the next time you see your container, you should have a mass of fine crystals. You're gonna filter using a small Buchner funnel, and you can look in the book procedure. It calls for use of Hirsch funnel, which is not available, right? Um, as you can see the difference between the Buchner funnel and the Hirsch funnel, right? Since in actually, if you study the the causes and the what can increase the crystallization um, and the growth of crystals, or the the generation of many nucleus with small crystals, then you should notice that this this architecture for this funnel is preferable for this purpose, right? But it's not a problem to get, I mean, to use this one as well. In some cases, the benzoin may not crystallize and may develop as an oil, right? Then, in order to facilitate crystallization, place your flask in an ice bath. Gently thrash the inside of the flask with a glass rod, which is metal spatula will sometimes work. If necessary, place a tiny crystal of benzoyl into your flask and swirl and cool, and see your TA to obtain a crystal of benzohynes, or you may be able to get it from another group whose product successfully crystallized as well. So, all this will contribute to the crystallization, which means that we will get the product more pure if we get the crystals, right? If we introduce a nucleus of a crystal from this nucleus, the crystal is going to start growing, right? And as a consequence, we are going to generate more similar nucleus of that crystal, which is what we want in order to get a more pure product. Also, low temperatures also increase the crystal nuclei grown, and as consequence again the purification, right? So um, all these steps are very important to follow in order to get crystals and a pure product. Then we need to wash the product with small volumes, around 7 milliliters of cold 50% ethanol, and then with cold water. Right, the benzohyne will dissolve in ethanol, but is much less soluble in water. To make sure your ethanol solution is not more than 50% ethanol, and cool your ethanol solution in an ice bath before using it. Dry compound and wait actual yield, right? Again, wash the product with a small volume of cold 50% ethanol, and then with cold water. First with ethanol, with cold ethanol to filtrate the product, and then the water to remove the the impurities that can be salts, can be the starting material in excess. That, remember, it was a salt, it will go with water, right, and other impurities that we're gonna have. Then the purification Um, we don't need in this case to purify the benzoin since we are getting crystal. If you don't get crystal, then that will be a problem, but we should get crystals in this case, right? In the spectroscopy of benzoin, again we need to obtain an IR spectrum. As always, you need to use the minimal sample possible, and it may not be possible to recover it. And you also need to get the proton NMR spectrum with chloroform and then recover your sample by putting the chloroform solution onto a wash glass and allowing the chloroform to evaporate. Very important, you will be working with sodium hydroxide solution which can cause chemical burns, which means that you need to be careful in this case to always use your protection media, your gloves, your goggles, your lab coat, and be fully covered and protected. And at the end, the the products or the waste from this reaction need to go into the proper waste container. The benzaldehyde is easily oxidized to benzoic acid by air, and benzoic acid could reduce the use. That means that we need to work fast. We don't want to have this starting material for a long time exposed to air, right? Um, we may choose to use a new bottle of benzaldehyde that should not be contaminated with the acid. However, if we are not confident of the benzaldehyde, we may have to perform an extraction to purify the benzaldehyde. And the extraction in this case is outlined in this section 6.4b, specifically in page 75. You will need not be performing the vacuum distillation at this time. The second paragraph of that procedure, only the extraction will be based on washing with water. You may not need to dry with anhydrous magnesium sulfate, and since you will be running an aqueous reaction for the benzoic condensation. However, you may need to dry to accurately weigh the benzaldehyde. That's very important that you understand. You need What is the purpose of drying the product? Mostly to measure the exact amount of starting material that you used, and then to finally calculate the yield of this reaction. For that you need the initial mass of your starting material and the final mass of your product. Pure both, right? If you weigh a wet starting material and then you get a pure product, the yield, according to your calculation, that is going to be lower than the actual yield, and it's going to affect your results and the explanation of your results, right? If we had the actual lab, only few groups will run this purification on 15 milliliters, as specified in the book, and then share with the others group that we have. And that's going to be all for today's class. Remember that you always can contact me using my email. Let me put the email here. And this is going to be my email. Remember that you can always Send me emails if you have any doubt regarding the experiment, the procedure, the mechanism. If you need, we can arrange individual meetings or by small groups if it's a generalized doubt or concern that you have. You always can contact me and we can solve it as quick and as best as possible. Hope you all have an excellent week and uh, a great and pleasant break, and see you for next class.